Okay, I think we can start it. So hello everyone. Thanks for joining today's demo session on Spring Boot microservices. Shiva is a trainer. He got very good experience on microservices and he's currently working on it. Shiva, over to you. Introduce yourself and you can start it.
Sure. Hi guys. Good evening. So myself Shiva. So I have around 15 years of experience. I've worked a lot on integration technologies, kind of work on APG and Google APG and APIs for the most part. I have good experience in microservices. I kind of have been working on Spring from last 8 years, I should say, probably. But yeah, Spring Boot is new, so kind of I don't. Even though we use a similar concepts, it's actually much better than compared to that of Spring, right? So primarily, the plan was to kind of cover the high-level overview of microservices. That's where we'll start. But end of the day, whenever you need to build a good API, you definitely need to understand why APIs are important. Second thing is how do we build good APIs? These are two different aspects, and they're very critical for you to build some good microservices. Okay, just having a high-level understanding of these concepts won't help. I would say that have a deep understanding of HTTP protocol, REST principles. That's when you can leverage the advantages of some frameworks like Spring Boot. Because Spring Boot has a plugin for every other thing, right? So the aspect is, it's important for you to know what is the situation or what is the scenario which you're trying to address and use the right packages and right, libraries to kind of address that requirement. But overall, this gives you a high-level idea of what exactly are the purpose of microservices, why do they exist in this world, how are they different from SOA, right? So those are the things which I would definitely cover because though that is the area where I primarily fancy existence of these services, and you see the performance and scalability and discovery. These aspects are very, very important when it comes to microservices. So we will start from there. We will understand microservices. Then we'll kind of, before even going into the actual Spring Boot and getting started, I would to cover these aspects because it is important for you to understand the HTTP and REST principles. Only then you would be able to define good microservices. It is not just a simple, technical training where I'm just gonna teach you how to write a simple Spring Boot REST controllers and say, hey, it's done. That is not going to help anyone because end of the day, you will be working in your actual jobs with respect to microservices, right? So once you kind of understand Spring Boot, once you know how do we build applications using Spring Boot. So I'm assuming some of things like like you are a little comfortable with Maven. You don't need to be super comfortable, but at least you need to know where, what, yeah. So okay, all right. Looks like yeah, there are a couple of people who are from .NET. So how, like, if it is .NET, will the challenge would be with respect to the language because we are talking about Spring Boot. So the concepts would remain same. This part would remain same. This part would remain same. Okay, but this part in .NET has to be the .NET components. So that is exactly where the things will change. Okay, but this is the part where it is all hands. You need to kind of figure out what would be the alternative for that. As in, what I mean is, what do you use when you say you're from .NET background? Like, what are you planning to use? Because generally they use C# for building these microservices. End of the day, it doesn't matter whether it is a standard REST service or whether it's a microservice. End of the day, if you build it in C# and then put it in Docker containers and run them across, it is somewhat similar, but not because the thing is, we have a very good ecosystem in Spring Boot. Okay, there's a very good Java-based ecosystem in Spring Boot which helps you uh, start up fairly quickly. There's a good head start. Okay, so I was also thinking of covering much in detail. For example, how does Spring security work? Spring repository. This is actually minimum thing which you need to know. Spring Boot security repository. OAuth, we can cover it if you're really interested in knowing the how all the OAuth flows works. I'm more than happy to explain because I'm quite comfortable with it. Then we will see how to document these microservices. This part would also again remain same because this is using something known as Swagger. Okay, it doesn't matter which technology you're using. The high level concept would remain same, but implementation would vary depending on the technology which you're using. Next is Spring Boot actuators. This is more of the health check thing. This you need to know because sometimes it is important to know whether the service is up or not. Okay, microservices are heavily driven by DevOps. Okay, that is the reason why the success of microservices is kind of tied with a little bit of DevOps. you should be able to scale up, scale down as per the whatever incoming volume of data or incoming volume of requests and so on. That is a reason why we are kind of ending with Dockers, because once you build your service, you need to know how to package. Remember when we used to do Hello World Java programs, we used to write a Java program, then we used to kind of package it as a Java file, jar file and give it, right? It's somewhat similar. We will build the Spring services or Spring Boot services. Finally, we'll document, or we kind of create a Docker image. That's exactly what you will hand it over to your teams, whatever team, like your DevOps team or whoever your delivery team. Generally, even this is automated in many scenarios because there will be already Jenkins jobs or maybe plugins which would already be doing this part in your companies. But if you have to do, you should know what is happening internally. So I will cover that aspect as well. So this is what I am looking to cover. If in case you guys need anything else, or if you want something specific, we can definitely discuss about it. Questions, queries on this part? Okay. All right. In that case, I will go ahead. I will show you, what exactly are microservices at a high level. So the plan is to kind of, walk you through what exactly are microservices. Once we kind of, once you understand what are microservices, you would understand why exactly they are coming into existence. Like the thing is, there have been a lot of technologies, different types of technologies which have come into place, all the way from, it being a simple monolithic application to client server, entire, Spring SOA, finally from SOA to microservice architecture. We will talk about SOA a little bit more, because the thing is, people try to cover or compare SOA versus microservices, but it is not true. Okay, microservice is also another type of service. That's about it. Okay, so people do not, they do a wrong comparison in many cases. That's like your tool comparison to tool comparison, which is not correct. Okay, so the basic philosophy of microservices is it's based on something known as single responsibility principle. It means it will just do one thing perfectly. Okay, that's exactly what it is supposed to be doing. So every service should do that one thing, whatever it is supposed to be doing, like let it be a business task or a technical task or whatever task for that matter, in a perfect way. That's exactly what we expect out of a microservice. Okay, so at a high level, these are the 7 principles, or I should say 6 principles. The 7th one is a little agnostic anyway. So 6 principles which we generally use for the most of the discussions. So we expect, at least there should be multiple services interacting with each other. That's fine. It's a multi-component architecture based services, and we will even define and discuss about the advantages and disadvantages of why or how do you split these services into components. That's again, it's more of a you will only get this by experience, because the thing is, there is no perfect right way or a wrong way. Okay, as you kind of learn design more and more, as you kind of learn more and more design and architect more and more applications, you will learn how exactly to design right. It's the same scenario. So anyway, so we need multiple components in order to have this particular thing. So and each of these each of these principles are further explained in the next slides. Okay, so like language agnostic, we know that the services are supposed to be language agnostic. Otherwise, that doesn't really solve the purpose of the challenge which we generally face with having multiple platforms, multiple languages, and everything, right? Decentralized database, we'll talk more about this, because we no longer go against one big Oracle database or RBAC database or any other database for that matter, or MySQL or MS SQL for that matter. Okay, we tend to keep the data associated with a specific microservice within to the service. That kind of helps a lot of different, and we'll talk about it why. Okay, they're independent. That we know that the services are supposed to be, they should be automated. See, the thing is, automated testing is one of the important aspects, because the thing is, the time to delivery or time to market for these services will be very less. Okay, we want to kind of just get going. If there's any change, we have enough test cases to validate our phases, and then it should automatically kick in. So while we are covering the course, I will also be emphasizing on how to do automated testing, or not even automated testing. I'll show you how to do mock testing and how to do unit testing. Both of these are important, because when a Maven build is running on your microservices thing, what happens is it automatically validates or runs your test cases for you before the build happens, and it is actually very useful, and we will see that with an example. Okay, so while even though I have not explicitly mentioned that as the testing part, it would be there. we will definitely cover those aspects because it's not a special topic. It's expected to be part of the implicit Spring Boot definition of a service itself. Okay, that's the reason why I have not explicitly mentioned it, but it will be covered. So there will be automated testing, which will be covered. Failure isolation is a standard principle because if one service goes down, it shouldn't so happen that all the other services are going down along with it, right? So there should not be any impact on that sort. Okay. So if you see component, so we assume that there should be at least one or two or more components in a given system. That's when microservices actually even fit into this whole thing. We will talk more about this when we have a practical example. As if you see the further slides, actually we have a slide and an example which explains how do we kind of segregate the systems. Okay, that time you will understand why exactly this really matters. Okay. The next thing is, the component should be able to communicate with each other through standard protocols. This is a very important point. The reason is, see, if there is no predefined communication or predefined protocol, there is no way you can communicate to that particular component, right? For example, if two services need to communicate, it should communicate over HTTP. That's what we expect. Otherwise, what will happen is, or it should be HTTP, or it should be based on an MQ system or some sort of a queuing system, right? Something which is predefined. That is exactly which is more important. We expect this to happen. Otherwise, there is no communication which can occur, or there is no contract which can be obliged. That's the reason why we expect this thing to be part of it. All right. Language agnostic. We just spoke about it. See, you can build the same service. You can build services in .NET. You can build services in Python. You can build any other programming language for that matter. Right? One service should be still able to talk to the other service over the standard predefined protocol. What is a protocol? It's nothing but a set of rules, right? So if you apply those rules, if you follow those rules, your services will still be able to communicate, and you will be able to, get the result which you're really looking for, right? So that's how we kind of design our services. We expect the microservices to be language agnostic. All right. So that's one of the other principles. Second thing is the third thing is a decentralized database. Each service is going to have its own database. That's something which is also critical, because until unless you know why exactly. So the thing is, this is called Z scaling. There are three types of scaling, right? Horizontal, vertical. That is a common standard which we always know, right? The horizontal scaling is known as X scaling. Vertical scaling is known as Y scaling. It is like X axis, Y axis. Okay. Now they have introduced something known as Z scaling or Z scaling, which is nothing but you kind of shred it, or you kind of have database level scaling. Previously, we used to always think like when you say database level scaling, it's more about increasing more hardware or replicating the database and so on. Things have changed drastically because now the databases which we tend to use are very lightweight, and most of them are NoSQL or key value based databases, right? So some of these things, based on the way you want your service to behave, you will take those decisions of what services would have made more sense, or what databases or what components would have made more sense. So we are expecting that each service or no other component can modify other services data. Like what I mean is, just because you have direct access to which database and which table to go to, there should not be for you to kind of do it directly. That's another thing which matters. Okay. So if one service is managing its own data, it should manage its data. They can get that data by making appropriate calls. For example, let's say there is an employee service. For you to authenticate or to get an employee ID, you should definitely talk to that person. It doesn't mean that you have to talk to a particular service. It doesn't mean you have to go and query the employee table, right? So there should be some service. There should be a way in which you can communicate, and you should leverage that abstraction for communicating instead of directly hitting the database or getting the data from the database. Okay, so that the service logic will take care of giving the appropriate whatever transformation or whatever it should give. For example, sometimes maybe the data in the database is just a simple record, but your service wanted a JSON or an XML. Who's going to convert it? It is supposed to be a microservice who will convert it, right? So that is the reason why we always recommend going via the service layer to the database, and there should not be any direct access to the database. Okay. So these are all some of the major principles. These are some of the main principles. We can actually even discuss them with examples as and when we kind of do the services themselves, because our services will follow all of these things. Okay. Next is continuous integration and continuous deployment. As I was rightly mentioning, right? I just mentioned that Maven will build your service, right? That is expected because we always use either Maven or Gradle, a build tool, which will be used for building the services. They are responsible not only for building, but they can also, do the deployment, do the testing for you. So that's the advantage. And personally, I think that the containerization, as in Dockers, really, or Kubernetes for that matter, they have really helped the Greatfold in this particular case of ensuring the independence and ensuring the microservices are. See, the microservice Dockers are hardly 100 MB, 200 MB, for the most part. So replicating them at the current scenario is not a big deal at all. We can replicate, like if you have 40 services, you can just replicate 40 instances of Docker, or just boot up 40 containers of Docker and it will start running. Okay, so that's how we scale nowadays. Previously, we used to, if you have to scale, you have to get a new server, hook them up, start working with it. It was never easy. Okay, uh, usual scenario is that you wait for at least 2 to 3 months just to get a server in place. So that dependency itself is now gone. Okay, and not only that, the other dependency which we are doing is because within a Docker we generally have only one service. That's the principle which we generally follow in many companies. So this Docker, if it goes down, it is independent of all the other Dockers. The Docker engine will not affect any other Dockers at all, right? So that's how you kind of establish independence within the services as well. So you'll be able to ship faster. So you need to have principles like continuous integration, continuous deployment in place to ensure or take advantage of, some of these things. So all of these things kind of go hand in hand, right? So each of these principles need to go hand in hand. Otherwise, one of the other things will break, right? So you need to ensure that some of these things are taken care for you. For example, decentralized database, when you test without any with knowledge, your test case will start failing. Okay, so some of these principles kind of go hand in hand. You need to kind of ensure that they're in the way. Automated testing, even deployment for that matter, it automatically tests and then ships. So the cycle is like this: it builds, test, ship, right? Ship is nothing but containerization and keeping the Docker ready, and you can really give this Docker to someone, or in fact, if you have a Jenkins or something, it automatically pushes the Docker to the appropriate location. So there are different ways of achieving this, and each organization will have its own ways of doing it. Okay, you need to know how the things are working, and then you need to adhere to whatever is your company using. Okay, so these are some things which that's when we are having the actual training. We will actually, if you have any questions, we can even talk about how would have they done it, because every company does it differently. Okay, failure isolation. Failure isolation, as I just said, if one of the instances goes down, it shouldn't affect any of the other instances, and this is achieved via there are different ways in which you can achieve it. One of it is Dockers. If a Docker goes down, none of the other Dockers are usually impacted. That's exactly how the Docker engine will take care. Okay, that is the simplest way. There are any even more complicated ways in which instead of doing a availability at a Docker level, you can do a availability at a service level and then kind of manage it. So there are different ways. The granularity changes there. Okay, but yeah, it's again, there's no major difference. You can use either of them and it will still work. All right. All right, next go to the problem definition. So usually, this is a sample use case which we generally talk to discuss about what is a microservice. Okay, so I will try to keep it small and explain what exactly it is. So let's consider a situation where someone wants to generate coupons based on a type of user. Okay, to do that, you need to have so it is easy to say this, right? Saying generate coupons for shopping online on basis of privilege given to the registered user. As per this definition, how many services do you think you will have? Right, because the thing is, there's a user privilege and then there is a coupon generation. So technically, you at least need to have two services: one for identifying who the user, what is the privilege level he is supposed to have; the other one for generating the coupon itself. Okay, so that's the way we kind of understand or define a problem statement and then start giving a solution for this particular thing. And if you see this is how the solution would look like, right? There will be authentication service which is really responsible for just authenticating and giving the appropriate response saying, hey, this guy is of this so and so privilege level. Once you have the privilege level, you will forward that privilege level to the discount service, and the discount service will say or will respond saying this is the amount of discount, or this is the percentage of discount, or this is the coupon code which he is supposed to use, and he will get the appropriate percentages. So if he's of platinum type, that coupon code will automatically give 20%, and if it is gold type, the coupon code will give 15% discount. If it's of silver type, the coupon code will give 10%. And in the worst case scenario, if we don't know who is the user, then still we are giving a 5% discount, because that's how the coupon codes usually work, right? We generally ensure that even if no one has anything, we still give some percentage of discount. Otherwise, there's no point of having a coupon at all, right? So this is how we tend to design a solution around microservices. This is a very basic example. If you see further, actually there's a lot of discussion about this. There's also, but if you see further, we also have further examples where how you can split some portal into microservices. We have an example of how exactly a travel portal would work both based on event model as well as request response model. We have event driven architecture based model. So there are different ways in which you can position your solution. Okay, so each of them have their own ways. Okay, no two microservices are same, and no two companies do it in the same way. This is a complexity which we always tend to deal with, and it is a common thing. We expect it to be like that because every company has their own set of challenges. Their legacies, the components will be different, and everything else will be different. So it is important for them to know what is best for them, and they generally tend to follow what is best for them. Okay, even that's the same case with any of the APIs. If you take, for example, Twitter APIs are nowhere closer to what PayPal APIs are. Okay, they use different standards. These guys use different standards, and so on. The reason why it is like that is, it is most probably, coming in from their criteria. For example, Twitter's primary purpose is to just get the tweets, whereas PayPal's purpose is something else altogether, right? So you cannot compare oranges and apples. That's the reason why you cannot compare two microservices, and get an exact saying, okay, this is my microservice better or his microservice better. There's no way to say that. Depends on the scenario. Okay. So we will discuss some of these use cases, in detail, and we'll understand why exactly the things are working the way they are supposed to be working. Okay. So this is on the theoretical purpose. Similarly, when we go further, we also need to know what are the benefits, right? So this is what I was saying. This is something as Z scaling. So this is actually sharding the database. That's exactly what we call, right? We kind of chop the database into multiple chunks, and we say, we leverage the advantage of those particular databases. So we will start slow. We'll start conceptually, but then there afterwards we will go towards HTTP, which is again, you need to understand the principles. If you see this particular thing, we will understand what is HTTP, what are the verbs, how does a request look like, how does a response look like, what is the difference between a service and an API. Okay, and then we will see what is the life cycle of a normal service, right? And then we'll talk about REST characteristic principles. This is also a very important topic, because these are the same set of principles which microservices follow. Okay, so you need to understand this. Actually, we will also cover this part called heteros, and we will actually do this with an example. Okay, even though I've not mentioned it here, it will be taken care for you guys, because see, some of these principles are supposed to be there, and I would always recommend the best possible ones, in fact. Okay, so we will talk about REST principles. We'll talk about heteros. Okay, we'll see how to convert between XML, JSON. What is JSON? We'll talk about what is JSON first of all. Then we'll talk about Swagger and how to create it Swagger. Okay, so if you see, this is what is a Swagger. I don't know if you have ever used a Swagger, but yeah, let me just quickly show you. So it's a YAML file which you tend to write. Okay, and then you will specify how does your microservice look like. So yeah, this we will generate automatically. We will see how the automated generation happens within Spring Tool Suite, so that you don't need to sit and write this thing, whatever that auto thing which is coming, right? But you need to know the tags. That's exactly what I would recommend. So we will discuss about Swagger and then talk about how do we document things. Okay. So at a high level, this is exactly is a starting point. There afterwards, we kind of go ahead with Spring Tool Suite. I would expect people to kind of install the Spring Tool Suite and have this thing working. And we will be using Spring Boot 1.5.x for now. Spring Boot 2 is fairly new. Okay, not many companies are still using it. It's not that I don't want to train on it, but it is just that even after learning morely, hardly 3% or 5%, not even 3%, maybe 2% of the companies in the world will be currently using it. It got released just like 2 months ago. Okay, so that's the reason why I would recommend learning Spring 1.5 instead of Spring Boot 2. Okay, so so then we'll go ahead see how exactly to create a Spring Boot project and then go from there. So I will show you different ways in which you can create it, because some companies do not allow you to use or may not allow you. It's all free. This is all free software only. STS is also free. This is called Spring Tool Suite. Okay, and you can see something like this. This is actually from Spring Framework only. Spring guys. Okay, this is pretty good. You can use this for most of your work. Okay, as it's also free. If not, if you are using normal Eclipse, then still you can go ahead and use it. For example, you can go to Eclipse Marketplace. Just give it a minute, because it kind of pulls the repository details. Okay, once it pulls the repository details, it kind of allows you to search. So if you search for STS in your Eclipse, you should still be able to add your Spring Tool Suite and go from there. Okay, it's a plugin. So this will help you build Spring microservices or Spring Boot microservices with ease, and then you'll be able to test and deploy those services as and when you need to. Okay. So we will see this in further detail, and then we will start writing the different types of services. That is exactly what we will get started with. And then we will have different components. For example, there are so many starters in Spring that even if I cover all of them, it will not be sufficient. It is ever ending, never ending for the matter. People keep adding. Okay, so you need to be a little comfortable with XML, and that is something which is needed. So primarily, what I would expect is some comfort level with XML, and why is this not? 1 second. So yeah, some comfort level with XML and little bit comfort with Java. Actually, some good comfort with Java would really be useful for you, because you will be writing the code primarily in Java. So that would really help. Okay. So any questions, any specifics which you would like to know? Okay. All right. So let's talk a little bit about why exactly microservices are important. How exactly is the job market for microservices? Actually, microservices are very hot in US. Okay. In fact, they're so popular that most companies are now moving towards microservices. Some companies have started a year ago, but they're still struggling, or they're still figuring out how do we do it right. And most companies are using it because they are having one or the other way to move towards cloud. Okay, this microservices architectures generally, see, if you see here, even the dashboard has a way to move towards the cloud itself. See this, install local cloud services. So there. Okay, so we can actually the thing is, we will go step by step for most of the things. Like, what I mean is, all the way from the introduction to each and every aspect of it. For example, creating a service and everything, it will be done step by step. Even the PPTs which I will be giving will be step by step. I'll just open up a PPT and show you how it looks. Uh, you know. Just give me a minute. So the thing is, as you can see here, we will go step by step on each and everything. So everything will be well documented. Everything will be, kind of going about each and every annotation you have. For example, this is a very simple annotation. Even for that, you will see what exactly happens there. How does the class get loaded? What happens when the class gets loaded? How to do auto wiring? Because I think most of you are new to Spring. That's what is my assumption, because you're never, I'm assuming that none of you have done any Spring before, so that it will start all the way from the scratch, where we create or we explain what exactly is Spring Framework, how exactly it loads the beans, or how does these annotations work actually. Okay, So all of these will be kind of explained stage by stage, as you can see. So this is how the annotations work. What exactly is enable auto configuration? What is auto configuration? What is component scan? So you need to know all these things if you really want to understand the internals of how Spring Boot is working. Once you know this, whenever you see an error, see, the challenging part is debugging services is the challenging part. Okay, if you know the internals well, you will be able to debug efficiently. If you don't know the internals, then that is when you will start seeing all weird sort of errors, because see, the thing is, Spring does a lot of work for you. Okay, it takes care of a lot of default stuff for you. For example, default error handling is taken care. Default conversion from Java object to JSON is taken care. Most of the things are taken care for you. You just need to know how to use this particular thing in a right way. Okay, so you need to understand how these things are working. For example, we will see what are the default beans which are loaded. There afterwards we have something like that component. How does that component really work? Okay, we will see how to print this hello world, not like a simple print of main method. That is a very common thing in Java, right? We will automated print. We will see how does this thing really been loaded. What does the difference between component and yet bean? How are they different? Okay, so we'll kind of go step by step. We will also kind of see how to use application property. This is what is called dependency injection. We will see how to do a dependency injection. Okay, so it's kind of step by step. We will go further to see what is auto-wired. All of these are common annotations which you tend to use, which you need to use. There is no other go if you're using Spring Boot for the most part. Okay, so this is the third. This is the level at which we kind of go slowly, step by step, understanding what does a profile mean, what does a auto-wire mean. So all of them have their own specific purposes. Okay, the reason why I'm not going into all of this today is, first of all, you need to understand the existence of most of these things. Okay, so once you know why exactly they exist, then you will understand how to use them. Okay, so that's what is the agenda as well. So if you see, first we'll start from this evolution of microservices, why they are needed, what is honeycomb analogy. Okay, I didn't speak much about this, but you need to understand this, because I will explain that in detail when we kind of go through this. Because let me switch to that. So if you see this, while we discuss about these architectures, we also will discuss about this. This is the honeycomb analogy. So you need to understand how this. So the thing is, it's very simple concept, right? How does honeybees build their honeycomb? They start small, go stage by stage, and they kind of build it in such a way that even if one of it is broken, it really doesn't affect the complete system. You can repair that only that specific honeycomb. That's exactly what is the nature doing. Okay, that is called organic growth within a enterprise, and this is the reason why microservices are popular and famous. Okay, that's exactly what people are trying to achieve. They Because when you will not know what is the purpose of your existence or that particular service's existence, but when you see in a bigger picture, they will have much bigger meaning. Okay, so that's exactly how honeycomb analogy actually works, and that's when you will realize why these, in fact, even all of these six walls have their own names and things like that. But anyway, those are all theoretical knowledge. That is not going to help you much. I would recommend having a practical knowledge and understanding how these things are actually supposed to work. That would be more better than anything else, right? So we will kind of cover that. We'll then talk about SOA. What is SOA? How is SOA different from microservices? Because I don't know how many of you know SOA, but that is fine. You need to understand this concept, because even in interviews, you tend to be asked the same question: how is it different from SOAP services? How is it different from REST services? These are the interview questions you tend to see commonly. Okay, even if I take an interview, I would ask the same thing to know what is the understanding. I would ask even what is the REST for that matter. Many people just say we have built REST services, we have built REST services. When we ask them what is REST, no one answers, right? So those are the challenges which we tend to see, and those will be the interview questions. So we will talk about those as well. As in, wherever you kind of see a tough challenge or a tough subject, we need to understand why that exists and what is the purpose of it. Okay, so we will talk about those. Then why do we still need microservices when SOA was good? This is what is the answer for that question. So you kind of understand that. Then we also talk about a little bit of ecosystem. So the thing is, there is a advanced training as well, which is more advanced. For example, if you use service discovery or service routing, there are other frameworks which you can use. Okay, those are all a little complicated. First of all, I am assuming that most of you are totally new to the world of microservices and they want to get started. Hence, we are keeping it at a beginner level to a greater extent too, and we can go all the way till intermediate when we talk about. So this is the intermediate level. If you touch this part, it's already intermediate level. You are already good at a point where in which you understand microservices, and now you're talking about security and then talking about open authorization. Okay, uh, these are maybe needed, may not be needed, depends on what kind of services you are building. If you are building a customer facing or client facing services, then you definitely need to understand some of these concepts. Okay, so that is the primary thing. And with respect to the job market, as I was already mentioning, right, there are a lot of openings within US. There are a lot of openings in Asia Pacific as well, for that matter. Europe is also picking up quite well, but the thing is, Europe has their own challenges at this point because of the new regulations which are coming called GDPR and so on. So anyway, that will take a little bit of time to kind of pick up back. But in India or in US, for that matter, it is pretty hot at this point. The other thing is, why is microservices important? Because the thing is, this is the first step towards going towards cloud. Okay, any of your services, unless they are not really containerized, you will not be able to move them over cloud. So that is the other reason why many companies are doing microservices at this point. Okay, so once you kind of understand why they exist, then you will be able to understand how and where it can be used. And there are different types of you know uh, things which you need to kind of the advantage of knowing microservices is that there are three certifications, or two certifications which are available in this particular field. One of it is from Pivotal. The Pivotal certification is something, it's a little advanced for now, because the thing is Pivotal actually checks your knowledge on their cloud. Okay, it is Pivotal is from the Spring guys. Okay, the guys who actually built or they own Spring on the commercial lines. Okay, so they kind of run a certification. It costs around $200. The exam is relatively tough. It is not easy to crack, but once you kind of get a hands-on experience, maybe 1 year down the line, you can definitely have 6 months down the line, you should be able to kind of target towards that direction. Okay, so that's something which would be helpful. Next thing is with respect to your prerequisites, I would say definitely hands-on Java experience would be very useful. J2E to some extent, fine. If you don't know, not an issue, because our course we will try to cover as if you know Java to a good extent, and then we'll go from there. Yeah. So if you have any questions or anything else, you guys can just reach out to the team. They will help you with the details. So that's all for now. In fact, if there's any need or any request which we need to add additional content, we can think about it. But for the most part, this content should get you a good head start on the microservices. Rest of them are pretty much in the similar lines. If you know how to use two libraries, you know the third library and how to use it for the most part. Okay, so that's how I would recommend you to grow. It's organic learning. That's all it is, right? So you kind of get started slow and go all the way to the next levels of using the different types of libraries. So that's all from me for the day.
Thanks,
Can you
Shiva.
tell me when is this starting?
Yeah, we will discuss that internally and let you know the date and time. Please stay tuned. Maybe in a couple of days we'll finalize it and publish it in the group.
Thank you.
Any more questions, friends? We are open for questions now.
What can we expect from this training from end to end?
End to end, you will be able to learn how to build services, how to create services, how to deploy services, finally how to make a Docker out of it and deploy them or give it to your DevOps team to deploy it into their actual systems. Okay, so this is all the way from starting a microservice till deploying or delivering it to the production. You can do everything. Okay, that is the depth and breadth. But when it comes to depth, you have to go into different layers. For example, implementing Spring Security, how do you do it? implementing OAuth, how do we do it? We actually go into, these are all examples. These are actually hands-on. All of these are hands-on. Okay. Whatever you're seeing here, for the most part, as soon as you see STS from here till the down below, everything would be hands-on exercises, including documenting for that matter. Everything will be hands-on.
Okay. Also, like I mentioned earlier, like I'm from .NET background. So this session, you said that two of the points are common, and the one building microservices with Spring Boot has to have the Microsoft components, right?
Correct.
Yeah. So it looks like that's the major part of the entire course, right?
So the thing is, this would remain same. This would remain same. In C#, if you want to build microservices, at this point, are you guys using microservices, or you're trying to use it?
Actually, we are slowly migrating to microservices with the Docker containers and stuff, but
so yeah, that is fine. Docker containers make sense. Okay, microservices make sense. Till here, everything makes sense. Okay, the only problem is the hands-on piece, right? Because the thing is, which framework have you decided to use for the
yeah, we are actually using Python. I'm not sure. I'm fairly new, and
using Python. You're using okay, all right.
Yeah. So I don't know. Does Python has a separate set of microservices framework or architecture?
Yes. No, the architecture remains absolutely same. See, it doesn't matter which language you're using. Even in .NET, the architecture is same. Okay. Just that the libraries are different. Okay. Now the thing is, even if you're using Python, you have to still learn Python, right? So because you're coming from .NET background, are you comfortable with Python?
I've been working on Python for past few months, so I'm now comfortable with it right now.
Okay. All right, even that's a good enough decision actually, because Python is not bad library. They also have good enough support there. But Spring Boot is the most advanced one. Okay. The reason why I say that is because, just give me 1 second, because as you're online, I'll just show you why exactly we still feel Spring Boot is #1 in this particular area. I kind of commonly get this question. See, I know .NET to a good extent, but I don't know. It really depends on the framework which you're going to use. Okay, so this is the location. We have something called initializer. Okay, so this is how we kind of get started. So if you see our depth and breadth, any framework, anything which we want, it's only click, 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 and that particular framework kind of gets included into the overall library. Okay, let it be included. Like for example, let's say any of the database integrations, it's just one click. Okay, it'll kind of add that. So the thing is, they have done it so well. So for example, if you want MongoDB support, reactive Redis or Redis or anything like that, you just need to select those. And if you want to integrate with Kafka, you can integrate with Kafka. If you want to integrate with Cassandra, you can integrate with Cassandra. So it's like just click, 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 and you will be able to proceed very quickly with respect to Spring Boot. That is the reason why many companies are actually going towards this direction. In your company, maybe they have a specific reason why they have selected Python. Okay, so I do know that there are many Python libraries on this, but again they might have selected so the one which there's nothing out of the box. Okay, as far as I know, that there is only one library which is there. So that is exactly where you must be. You guys must be using this. It is called Flask. That's what I was actually searching for. It is called Flask. Okay.
Yeah, so, Flask and Cherry Pie, two of those things we are using.
Yeah. So this is what is Flask. So that's a different way. But again, the concepts would remain similar. Just that the way you will implement would be different. The reason is because they use Jinga templates and the RESTful dispatcher. So see, this will remain same. This is how even Java would be. If you see this, I will show you one. Just because you are asking me, I will show you that particular thing. So for example, if you see our controller, only thing is we come from Java side, so that's the reason why you kind of see it slightly differently. But if you see this, get mapping of that's exactly what you're mapping even in this. Okay, app route /hello. Okay, this will automatically give hello. So if you want to handle post, you will have a specific thing called post, and then you will specify. It is somewhat similar, not 100% same for sure. Again, you have to do some sort of a mapping. But at a conceptual level, everything else is same. Once you build this Python thing, you will still need to build a Docker out of it and then hand it over. See this? This is exactly how you give it. So log in and you will specify which method it is, whether it is get or post. But the logic would remain absolutely same. See, that's exactly what I'm doing with get mapping. So it's like HTTP method get. See this? That's exactly what it internally does. Technically, everything else will remain same, man, because it doesn't matter which technology you are building your microservice in. Okay, conceptually they will absolutely remain exactly the same. But the only difference is when you're integrating with, for example, when you're integrating with other frameworks, it varies. Okay.
Okay.
Any other questions?
Hi, I have a quick question. So Spring Boot and microservices both are same, or Spring Boot is one way of doing microservices?
Spring Boot is just a framework which allows you to do microservices in Java.
Oh, okay. So what are the other microservices we have?
Yeah, so you see this is Flask. This is one for Python. Okay.
Oh, okay.
So similarly in .NET they have multiple frameworks. Actually, I do remember that .NET has a framework for this. So there is a direct. Actually, they are working on it. Actually, Azure has something. Actually, they even have a serverless computing model for that. So they are working on it as of now. See this .NET Core microservices. Actually, they do have a way to kind of do that. Actually, so it is out of the box. They generally use the web APIs to do it as of now still, which is a little old way. Because web APIs have been there from last 4 years. They are not still very efficient though. But yes, there are different ways in which you can build the microservices. Spring Boot is the one which most companies are using as of now because of the various reasons, right? See this is the reason.
Yeah.
I can just select the dependency and I can just hook in. That's the advantage of it.
Okay.
Any other questions? Okay. If not, Marty, back to you.
Yeah, thanks, Shiva. Thanks for an excellent demo. Friends, as I said, we'll publish the start date and the time of the training session. And I'm going to share this recorded session to everyone so you can have a look at it when you get time again. That's all from our side. Thanks, guys,
Right.
and good night.
Thank you, guys. Bye.
Thank you. Good night.